One, many of you that didn't do this when I sent out progress reports have messaged me by now. Some of you messaged me but didn't tell me your score, so I had to go back and look. Make sure you are telling me your score, and it should show up whatever your score is. If you have not gone back to do this, go back and do it. Send me a message saying you did it. That's the only way that grade will get changed. Because yes, I can see it on my end, but I want you to take the initiative to say, I did this. Can you fix my grade, please? If you've done this but have not messaged me, I'm going to try to give you time at the end of class to message me so that you don't forget. The one from last week? Yes. Yes. So at any point in time, you want to go back 2 weeks from now and fix, let's say you got a 75, you tried it maybe 4 times, you got frustrated, I'm done with this. And then weeks from now, you're like, that 75 could be the difference between a B and an A B plus and an A. And you want to see if that is the case, so you go back and you retry it. You would just send me another email, hey, I fixed this one, this Khan Academy quiz, and I got this grade. I did want to show you a couple of things because I saw some confusion. And it was really whether to use parentheses or not. So if I had something like 2 times the difference of x and 3, that's probably not the best one. But we know we're going to multiply. Oh my goodness. So if we know we're going to multiply by 2, and we know we're subtracting. But because 2 is being multiplied to the entire difference, we need parentheses here to show that this is x minus 3 and 2 is being multiplied to everything. So if you got something like this, you see that these 2 were correct, but things like this was not. We had some other issues that we put like a dot instead of a minus. We were multiplying the wrong thing. You started to distribute. They don't want you to actually simplify this. They just want word for word whatever it is. The sum was kind of similar because you're multiplying 5 to the sum of. But if we get something like this, 7 minus the product of 3 and x are being multiplied, and I'm just subtracting that from 7. So sometimes you need parentheses, sometimes you don't. And you have to be able to figure out which ones do and don't. Did you have any other Khan Academy questions from the one that was remote right? For this.
So with the parentheses, I have a little bit understanding like the math questions. It automatically sends me back a question wrong. So like let's say under hinge I got it correct, but that would just still count towards the 50%.
Right. So for that, anytime you get help, choose like an article, a video, get hints, it marks that question as wrong. So if you are looking for, you want to get a 75, you have to get at least 3 right without help. Now that doesn't mean you can't use the help, that just means you may need to go back and retry it again. Other Khan Academy questions? Remember that you do have two due this week. Some of you have started those already. And some of you may have been waiting until you finish what we're going to do today, which hopefully after today now makes more sense. So I saw a lot of different answers for 2. Anyone want to share their part A? Square root of a number. We could say, if we said subtracted by 4, usually we said, we'd have to say 4. Let me make sure I'm not mixing that up. That would be fun. What we couldn't use is the word less than there, because that would mean it's switching. Some of you use less than, but if you said 4 less than the square root of a number, that would work. If you just said the square root of a number minus 4, that would work. Someone tell me what they what would be. Oh, that's gonna.
Square root of a number, and
The and tells us to do what?
To use the square root over both numbers.
So we can say the square root. We couldn't just put and there, only because it's not telling us that we're subtracting.
Or negative 4 and negative 4.
We wouldn't say negative 4 in that case, because then we would think that we're multiplying those. So how could we change that? So that we are still saying it's the square root of both. But also that we're subtracting. Sophia. Easily. Tell me what you have. The square root of 4 less than 100. The square root of 4 less than 100. That could be perceived as this, not necessarily the x with it. No. A lot of these you really have to think about. So I'm actually going to say that one would work because of the way it's worded. You couldn't say that 4 is not included in that one because of the lesson, so I'm going to give you that one. Square root of 4 less than if we're using our parenthesis phrases, that may also help. The square root of the difference of, then it's implied whatever is being subtracted is underneath. I'm sure there are some other ways too, but we just have to think about them. Do we have questions on either of those? I feel like going to words is probably more challenging because it could be a multitude of things. But going to the expression isn't as bad because there's really only one way to write it. For number 4, part A, the product of the cube root of 5 and 800. What do we have there? What is that?
Plus x.
Where does it tell us to add?
With the and.
So this and goes with the product of, it's saying those two things are being multiplied together. So we're not adding. Where would our x go? Underneath. Yes. I think if it said the cube root of the product of, then yes. But because it says the product of the cube root of 5 and the number, it doesn't necessarily mean that that number is underneath. So in this case, we could use like a dot, or if we want to put x in front. That would still mean the same thing, even though they're backwards. What about the quotient of a number cubed and 5? And then, was your hand raised? No. What does quotient mean? You left? Division. So, and we're going to try to avoid using our division symbol, but use it as a fraction. So we know we're going to have some fraction. We need a number cubed and 5. Regina. Anyone else have the same thing? Do you have something different or you're thinking you agree? A number cubed means we're raising it to the third power. If it said cube root, we need the symbol from before. And then it's being divided by 5. So that would work. Do we have questions on 4? Keep this. As we're talking about keeping things, I did not mention this before, but towards the end of this unit or towards the end of each unit, I'm going to do like a binder check. It doesn't necessarily have to be in a binder. And it's just so that I see that you're keeping the things that we're using in class as well as have some sort of organization. So far, you should have the Desmos tip sheet as you did the first day, the course calendar, the activity we did on the first day. You don't necessarily need that, but if you have that, it's fine. The translating notes, the simplifying notes, this flip chart. If at any time you are missing any of those things, there is a crate. Regina, Gianna, either of you point to this dark blue crate. Everyone see this dark blue crate? There are extra copies of whatever you need in there. If you can't find it, just let me know. Take out your simplifying notes if you haven't already. If you wanted to try using the algebra tiles, I do have those today. So if you want those, raise your hand and I'll get those to you. Does anyone need another copy of those notes? So last class we talked about how to model with algebra tiles. We started simplifying with algebra tiles. Then I showed you how to do it algebraically. Today is going to be, we'll do any problems that, really I just have a couple that I want to do with you, and then I'm going to let you practice for a little bit, and then we're going to keep on going. So we're going to do 4 and 5 together, and then I'll let you practice some on this page. So starting with number 4. If we were to do this using algebra tiles, we would need 2 different things to represent the variables, since we have 2 different variables here. And the algebra tiles I have don't have that. So this one we really have to do by hand. Do we have any like terms? Terms that have the same variable? And then what does that mean? -6a and -5a. When we are simplifying, we're doing whatever it says. So -6 minus 5 would be what? 11a. Do we have any other like terms here? No. So this would be our answer. It is the most simplified as it's going to get. If you have multiple variables, put your variables in alphabetic order. If you have multiple variables with exponents, the highest exponent goes first, no matter the variable. No matter the variable. And then it goes in ABC order from there. Do you have any questions on 4? Now we go from something that wasn't that difficult to all these fractions. Again, this is something we couldn't really do with the algebra tile because I don't have decimal or fraction algebra tiles to represent this. But the process is the same. Do we have like terms? Yes. Which ones? Okay. What else are like terms here? 1/5 and -1. Even though one's a fraction, one's a whole number, they're still constants. They don't have a variable, so we can say that they're like terms. Now, foreshadowing. This first test we're going to do, you'll have access to your calculator. So I say that because some of the tests we do, there will be non-calculator sections. This will start to prepare you for when you move on to geometry, advanced geo, and higher level classes. Some of them do non-calculator sections. So we could do this in the calculator, but we're going to do it by hand. So if we were to combine these two, could we combine them as is? No. Hila? Yes. What would a good common denominator for this be? You guys can say that loud. 6. So this one's already 6. When we change this to 6, we're doing what? You can say that loud. Yeah. But what we do to one piece of the fraction, we have to do to the other. So we also have to multiply this by 2. So we now have -4. The negative could really go out in front. It's not really -4, but 6p. We're going to rearrange this. Let's also do the same thing for our 1/5 and our -1. We need to have a common denominator of 5. So all of your whole numbers, every single number up here, I think I said this before, are really fractions. They have an invisible 1 underneath. Regina? -5. Plus 1 minus 5. These are 5s. Now we can simplify, combine our left terms. -4, and we're just doing our numerators, not our denominators. -4 plus 5 will give us how many p's? 1. Otis?
1 over 6p.
1. Positive 1 over 6p. Otis,
And negative 4.
and if we're subtracting this, 1 minus 5 will give us -4. Our denominator was 6. Is there anything else we can do to this? We can't simplify these anymore. We don't have any like terms. This would be our final answer. Before I let you practice them, do you have questions on how we got that process, anything like that? After you do this algebraically or by hand, you could go back and double check if I put this in the calculator. I'm going to show you. You could check yourself in the calculator. I'm going to show you more calculator Desmos tricks in our next lesson. But everyone follow along. Okay, so to get a fraction in here, we're going to get alpha y equals. So alpha y equals, everyone should be putting this into the calculator. And it's going to be this first one that says n over d, your numerator over denominator. And when you press enter, you're going to get a fraction bar. So alpha y equals 1 or enter, and you will get that fraction bar. If you need a negative, like this first one is negative 2/3, use this button down here. When you go out to the front, hit negative 2/3, and I'm just using my arrows to move. And I am adding 5/6. We do the same thing. Put back left, and then go back and grab another fraction. Alpha y equals, and then 5/6. It will give you the most simplified answer, so you don't have to simplify it. But it's a good way to check yourself. Anyone need me to do that again on the calculator? Yes. I'm going to do it with the other fraction. 1/5 minus 1. Alpha y equals. Go into the first one or hit enter. Put in your fraction. You can use your arrows to move around. You need the right arrow to come out of it. And then after you have everything in there, hit enter, and it will give you the most simplified fraction. As you're working, if you need to double check something in the calculator and you aren't sure how to put it in, or if something was wrong, just raise your hand, not one. Alright, I'm going to give you a couple that I want you to try. Number 3, number 6, and number 7. I want you to try those 3. I'm going to give you 5-ish minutes, and then we'll come back and talk about those. Starting with number 3. Anyone have an answer they want to share? Most of the answers I saw for number 3 were correct. And 14 minus 5. Who else had the same answer? Look at that. Did anyone need to see this worked out? Or have questions about that? For number 6, who has an answer for this they want to share? not a concept for this one. It's okay. It's the densest. You had the same answer. You all had the same answer, and we're not comfortable about it. But you guys did great. Anyone need to see this one work out? So for this one, we had the k's as like terms. When we circle or square or whatever shape we're doing to our like terms, make sure you include the operation that comes before it. That way we know what we're doing to it. There's an invisible 1 in front of this k, so we'd be doing 0.25 minus 1. That would give us that negative 0.75. And then because these both have a k, we put that at the end. Then these two constants would also be like terms, because they don't have a k. And we could take this positive and subtract 3.5. So 1.5 minus 3.5 would give us 2. It'd be negative. I don't know why I started with that. Because these people are so you can double check yourself with your calculator. Who wants to share their answer for 7? I saw quite a few of us had an answer for this one. I don't know. Anyone have anything different? Or, sorry, if we have the same thing, anyone have anything different? Unless I did see your hand.
I simplified or 712.
Yeah, what?
Oh. The 7, I simplified the 712 to 3
So this one, can this be simplified?
I took it back.
Does 7 go into 12? So that one would stay the same, but what about this one? Yeah. Because for that to be 2/3. I'm actually going to move that to be third. That's the right answer. So some of you were really close. You just need to simplify that answer, that 4/6. But we also want to make sure we're putting the variable first. Right? Have more confidence. You guys got this. Do you have any questions about this so far? We're going to continue in these notes, but now we're going to take it a step further. Now we're going to get into distributing and stuff like that. So going to the next page. We're not going to do all of these problems, but there are some that I want to show you and try. So again, I have the algebra tiles. If you want them, let me know. I'm going to show you how to do both the algebra tiles and do this algebraically. The algebra tiles with the distributing gets messy because there's a lot. Because if I were to represent this with algebra tiles, I have to do what's inside. So let's do that. How would I represent x plus 2? I'm going to 1, I didn't think first. 1, 3, and 2 rows. Because we are multiplying this 3 times, I need to take this and do this 3 times, or 2 more times. So if you wanted to draw this, you're more than welcome to. You don't have to draw the algebra tiles unless that helps you see it. So how many, or what would we have here after all of that? I heard 3x plus 6. Now, If we were doing this algebraically, we're taking this 3 and multiplying it to everything in here. We're really just multiplying it to the numbers. So we're multiplying it to the 1 in front of x. 3 times 1 would give us what? We would say this out loud. 3, and then we put the x back. 3 times 2 would give us 6, and we put whatever symbol is here, unless this was a negative or something was a negative and it changed. So we get the same answer either way. This one has a little bit more steps to it. Questions on that? That was an easier problem versus some harder ones. This one is about same level. Doesn't include the only ones. So again, we'll represent it as algebras and then we'll do it algebraically. How would we represent negative x plus 1? One of the red squares or the rectangles? Mm-hmm. So negative x plus 1. And if I were multiplying this twice, I would need I think it was this class I said if you are drawing the algebra tiles, anything that's negative you can shade. That would tell you it's negative. Anything that's positive you need to draw square. If we were doing this, sorry, I skipped ahead. What would this total represent? Yes. X plus 2. If we were to distribute this, 2 times negative 1 gives us what? Negative 2, and we would include x afterwards, and then 2 times 1 would give us a positive 3. Do you like algebraic way better, or the algebra tiles way better? Algebraic way? And then algebra way? Let's skip a couple pages. Find a page that looks like this. This one I am not going to use algebra tiles. We could, but it would get messy really fast with not in this case. I was thinking we had 0 pairs. But there are 2 different ways to go about doing this. Algebraically. One would be to do whatever inside first. So here we have like terms. We can combine those like terms, so let's do that first. What are our like terms? If we combine these 2 negative x's out loud, what would we get? Negative 2x. So be careful with our subtraction. We are starting at a negative and we're going further back into the negative. So negative 2x. And then we have these constants. Plus 3 plus 2, that would give us so now we need to distribute the 2 to everything. 2 times negative 2 would give us negative 4, and we then put the x. 2 times 5 would give us x. So our final answer should be negative 4x plus 10. I'm going to show you the other way you could have also done this. I'm going to rewrite this down here. If we forgot that we could combine the like terms, this way would also work. If I started off distributing, one, you're distributing a lot more, but it's okay as long as everything else works out. So 2 times negative 1 would give us 2, and then x. 2 times 3, 6. We have another negative 2x, and then 2 times 2. Then we would need to combine our terms. So just as before, we have our x terms. Negative 2x minus 2x would give us what? Negative 4x. And then 6 plus 4. So we get the same thing either way. It's just how you see it. As long as you do both steps, the order doesn't matter. Do you have any questions about that? Now we have this one. What do we think is the first step?
Multiplying 3 into negative 2x and negative
That is correct. Could I add these two things together? No. This is in parentheses. Call it like a bubble, wall, whatever you want. It can't get out of that until you've done something with it. So multiply 3 to both. What would that give us? What is that?
negative 6x minus 3.
After we've distributed both, we no longer need the parentheses, but we do have to break everything else down. What would be our next step? Combine the terms. Kayla, what are our like terms? When we combine those, we'll get negative 2x minus 3. Questions on this? So far, how do we feel about distributing and simplifying? Good, okay, not good? We're going to do 2 more together. 3 more together, and then you'll have more time for that. It's the same thing, we're just doing it multiple times. So anywhere you see parentheses, you're going to distribute. You can do this at the same time, or you can do it separately. Does not matter. I'm going to do them at the same time to take up less space. What would this be after we distribute? You can say it out loud. 4x plus 8. Bring down this negative 3x. And what would this be after we distribute? You can say that out loud. Negative 2x plus 6. So anytime you have that negative, if it was positive, just make it negative, don't put plus minus. Our next step, combine our terms, which are what? 4x, negative 3x, negative 2x. So 4 minus 3 minus 2 will give us what? Negative 1x. So you can put negative 1x, or you can just put negative x, either or. Then we have 8 and 6. We add those together, we get 14. So all of those things, we had a bunch of terms, and now we only have 2. That's our goal, usually, again. Simplify them all as much as possible. Do you have any questions on that one? I have not been estimated. We will remain this before we do our next one. Same thing. Start distributing. As we distribute, what would we get? You could say this out loud. Negative 6x plus 2, what would the next piece be? Plus, not 3. This one lost one here. Another 6x minus 3. Then we're going to bring down these two minus x plus 2. Combine all of your x's together. You have negative 6x plus 6x minus x. What would that give us? Negative x. And then positive 2 minus 3 plus 2. Not 0, but you're close. Yes. So if you've not tried the combining lit terms with negative coefficients and distribution, hopefully you'll be able to try that and it'll make more sense now. The other one, combining lit terms with rational coefficients. So we've done some of that when we had the rational, but not with parentheses. We're going to try a couple more. I'm not going to do number 1, but I do want to mention this. Here's a 1 right there. So when you're distributing a negative. We're going to do 7. And then we'll let you practice some, and then you'll have time to work on concept. So even though there's fractions in there, same thing. And if there were a fraction in front, you would do the same thing as well. We're going to distribute this negative 4 to everything. Here, a negative times a negative will give us a positive what? 12a. Here, when we multiply this number to this fraction, think about this like this. All whole numbers are really written over 1, so you're only multiplying this number to the numerator. So negative 4 times 5 and divide that by 4. What would we get? Oh yeah, this is negative also. This should be positive. 5. A. Then we're back to numbers. Negative 4 times 5 will give us a negative 20. And then we're going to bring out our formula. Our like terms are what? And what? So 12a plus 5a plus 4a gives us, if we do this out loud, how many a's? It's 20 something, not 3. It's 21. And then a minus 20 would just give our back. I'm gonna find what the rational looks like just to make sure we're all on the same page there. If you wanted to, like at home you don't have these calculators, but if you wanted to check yourself using Desmos, So I'm gonna do the example where we're multiplying -4 and -5/4. You can use this keyboard and just type them in, or if you're using your own keyboard, you can just type them in. Because the division, it'll automatically make it a fraction, and it will tell you what that answer is. So use Desmos at home, unless you have your own calculator to help you with those. Okay. So of these problems here, I want you to try 5 and 6. You can try others if you so choose. After you finish at least 5 and 6, I'll give you time to work on the 2 Khan Academies if you have not already. So try those. If you finish, you can go ahead and start your Khan Academy.